7.3 proven quadrilateral is a parallelogram. All right, so we got something similar that we've seen before, except this is the converse. Before we said if it's quadrilateral, then the opposite sides are congruent. This one says if both pairs of opposite sides are a quadrilateral or congruent, then it is a parallelogram, right? So just using the converse and going backwards. And the same with this one, parallelogram, opposite sides. If both pairs of opposite angles are congruent, then in fact that this is a quadrilateral. So before I was using quadrilaterals to prove the sides or the opposite angles are congruent, but now I'm using the opposite sides congruence or opposite angles congruence to show that this is a quadrilateral. Alright, so first question, quadrilateral WXYZ. We got three angles listed here. We got angle W, X, and Y. And we're going to try and show that this is in fact a parallelogram. So if it's a parallelogram, well, then it's a quadrilateral. If it's quadrilateral, then the quadrilateral implies that there's 360 degrees in all these. So if I add these all up, so 42 plus 138 plus 42, and then my last angle here, angle Z, I'll just call it plus Z, and all four of these should equal 360. So let's add these up right now. We got 170, we got 180, and we got 222 plus angle Z is equal to 360 here. So we got 42, 138, and 42. That's 170, 180, 222, and then we're going to subtract 222 from both sides here. That goes away. Bring down my Z. And when we subtract here, we see we got 138 degrees. So angle Z is 138 degrees, angle X is 138 degrees. We also said angle W is 42 degrees, and angle Y is 42 degrees as well. So the opposite angles are in fact congruent, the same, therefore this is a parallelogram. Okay, for this next one here we got for what values of X and Y is a quadrilateral PQRS a parallelogram. So in order for this to be a parallelogram, PS must equal QR, right? Opposite sides must be congruent. So, and the other piece here, the other one was that PQ must equal SR. All right, so if I put this on, if I put these information in here, so I got PS, which is equal to Y, QR, which is equal to X plus Y, and then PQ, which is X plus 9, and SR, which is 2X minus 1. If you notice, one of these, this is actually plus 7, not plus Y. So plus 7. So in this equation, I have a Y and an X. So I have two different variables in this equation here. Y equals X plus 7. And then on this side, I have X plus 9 equals 2X minus 1. So what I'm going to do first is solve for X from PQ equals SR first. Then go back and plug in that X value into here and then solve for Y. So I'm going to subtract X from both sides here. That goes away, and I got 9 equals 1x minus 1. Then I'm going to add 1 to both sides. And I got x is equal to 10. So there's x is equal to 10. Now I know that. And now I'm going to take that and I'm going to substitute that in for x. So now when I go solve y, I got y is equal to 10 plus 7. So y is equal to 17. So I was able to solve for x and y here. So here's two more theorems coming your way. All right, this one we're proving that this is a parallelogram again, and this is probably the shortest of them, right? So we said so far if opposite sides are congruent, it's a parallelogram. If opposite sides are parallel, it's a parallelogram. Here this is saying if one of those opposite sides, all right, so one of the opposite sides, BC and AD, is both congruent and parallel, right? So if just one of those opposite sides are both parallel and congruent, then this is a parallelogram. You don't even have to worry about A, B, and C, D. They're automatically going to be congruent and parallel just by saying that B, C, and AD are both parallel and congruent. This makes A, B, C, D a parallelogram, which then all the other properties are true too, right? So then these two sides will be congruent as well. these two sides will be both parallel. Opposite angles are congruent, right? All the other properties there are going to be congruent as well. And then one more property here about parallelograms is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram as well. And this is the converse, right? So before we said in one of the other proofs here, one of the other theorems, if we drew a line from AC, and we drew the diagonals here, we said the diagonals here bisect each other, right? So then this piece here, this side here will be congruent to this piece here, and this piece here will be congruent to this one, and this one just using the converse. If the diagonals bisect each other, then in fact this is a parallelogram. Alright, so for what value of x is a quadrilateral CDEF a parallelogram? Well, for this to be a parallelogram, the diagonals need to bisect each other here. We see that CN and NE are congruent, so this, FD did bisect CE, and now we need to make sure that CE bisects FD. So we need to make sure that FN is in fact equal to ND, and to make that true, we're going to say that, well, I need 5x minus 8 to equal 3x. And I can do so by subtracting 2x from both sides. 5x from both sides. And we get negative 8, careful, make sure you bring down the negative, equals negative 2x. And then going to divide both sides by negative 2. And I'll bring this up here, and I get x is equal to 4. So as long as x is equal to 4, then this side, 5x minus 8, or 5 times 4 is 20, minus 8 is 12. I'll get 12 here, and I get 12 here, and then I can show that Fn is also congruent to ND, therefore CE does bisect it, showing that both diagonals bisect one another when x is equal to 4, therefore a parallelogram. Okay, so I want to show that this quadrilateral here is a parallelogram, and I'm going to go back to my theorem that says if I could show that one pair of sides, or one pair of opposite sides are both congruent and parallel, then it's a parallelogram. So I want to show that AB is in fact equal to DC, and then I want to show that AB is parallel to DC. So I need to show that they're congruent or equal, and AB is parallel to DC, right? So I want to show both of these, however we want to do this, right? So I'm going to find the distance of AB, and I can do this with the distance formula or the Pythagorean theorem, and I'll do one of both just to bring back some memories. So AB is going to equal, so if I use the distance formula, d is equal to the square root of, I got x sub 2 minus x sub 1, so difference of my x's squared, plus difference of my y's squared. So when I plug this in, so I got a is, here's a, got a is negative 3, 3, b is 2, 5. So when I plug this in, I get negative 3 minus 2, so subtract my x values, plus 3 minus 5, subtract my y values, I get d equals, this is negative 5 squared, plus negative 2 squared. Just remember when you square these numbers should both be positive at the end of this. So I got 25 plus 4, and I got d is equal to the square root of 29. Alright, and I'll do the same thing with DC here. And for DC, I'm going to use the Pythagorean theorem here. So I'll use a squared plus b squared equals c squared. So I'm going to construct a triangle here. So I'm going to make a triangle from D and C. So I'm going to make a right triangle here. So DC will be my C here. And A is going to be the run or rise, doesn't matter. So if I count, I got 1, 2, 3, 4, 5. So A is 5. And then B is 1, 2. And B is 2. So when I do this, I get 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. 29 is equal to c squared. Square root both sides. C is equal to the square root of 29. And remember, C represents the side DC, and AB represents D. So they both have the square root of 29. So this is the square root of 29, and this is the square root of 29. So far, check. They're both the same. The other part is now I just got to find the slope of AB and DC, right? So the slope is easy enough. I'm just going to count my rise and run. So my rise is 2. So slope of AB. I got my rise is 2, and my run is 1, 2, 3, 4, 5. My run is 5. And I'll do the slope of DC here. All right, so I kind of have this here already. I did it before. My rise is 2, and my run is 5. So both lines are parallel, and both lines are congruent. Therefore, this is a parallelogram by just showing one pair of opposite sides, both parallel and congruent. All right, and then we're going to finish this off with a proof here, and this proof is a little longer than usual. We got about 15 steps in this proof. Yep, pause here and try to do it on your own. All right, so we're trying to prove that ABCD, so this big parallelogram here on the outside, is a parallelogram. Right? We're trying to prove that ABCD is a parallelogram. We're given that DEBC or DEBF is a parallelogram, so we know that. I'm going to highlight this here in pink. So we know this part here is a parallelogram. Okay, so that means the opposite sides are parallel and congruent, right? So DF is congruent to EB and parallel to EB. We know DE is parallel and congruent to FB. We know that angle ADF here, or I'm sorry, EDF is congruent to FBE. DEB is congruent to DFB. So we know these two angles are congruent. We know these two angles are congruent. All right, these two sides are congruent. These two are congruent. These two are parallel. These two are parallel. All right, so we got all that information, and I'm just gonna erase this just to keep it as clean as possible for now. But that's what we got so far, right? So let's see what we have, and this one's set up for you nicely. We gave you guys all the statements in this one, so we really just got to fill the rest in. So it says DE is congruent to BF, and I'll label my diagram as I read these. So DE is congruent to BF, and DF is congruent to EB. Alright, so it's given to me that this is a parallelogram, so therefore, by definition of parallelogram, opposite sides are congruent. Alright, so I'll call this the parallelogram. Opposite side theorem. Right? Saying the opposite sides are congruent. Alright, then this one brings back some memories, right? I'm going from congruence to equality. So DE congruent to BF and DE is equal to BF. So I'm going to be using some addition and subtraction, which you'll see in step 4 and 5. But before I do so, I need to make my congruent sign into an equal sign. So this is just definition of congruent segments. Alright, then I got AE is plus EB, so let's see where we're talking about. We got AE, which is this part, plus EB, which is this part, is equal to AB, so the entire thing from here to here. Right, and then the same thing here on top. So DF, alright, so DF here is DF is the big one. So DF here plus FC is congruent to DC all the way, right? And this is just the segment addition postulate. All right, and then we got that AE plus DF is equal to AB. So AE is good. EB is swapped out with DF, and we could do that from here in this step here. All right, so, oops, sorry, not the, that's coming from here. All right, so I'm doing a little substitution there, and then the same thing is happening here, that DF plus FC, now I said FC and AE are being swapped out, and that's coming from here, right? So this is just by substitution. Right, so I changed my statement ever so slightly. I changed EB to DF, which came from step 3, and FC to 8, and FC to AE. So there's a little correction here. AE to FC, that came from up here, where it's AE is equal to FC, not from DE equals BF, sorry. So I had the line going this way. It should actually be coming from FE and AE are congruent or able to be substituted because of my given here, AE to FC. So let's make that correction. So it's not coming from, that's what I had before, it's not coming from there. It's actually coming from this statement here, right? So AE equals FC, and that's my substitution here. And then I'm saying here that AE is equal to DF, so I have this statement here. AE plus DF is equal to AB, and AE plus DF is equal to DC, so therefore AB is equal to DC, and that's by substitution as well. Alright, so now I was able to show that one pair of opposite sides are congruent, and now I want to go back and see if I can get opposite pair, the same opposite pairs to be parallel as well. So here in this statement here, I got, let me finish this one. AB is congruent to DC, and that's just bringing back equality to congruence here, like I did in this step. Same step is here, and this is just definition of congruent segments. All right, and then I jump into the parallel statements. DE is parallel to BF. DF is parallel to EB, and that's because I know that this is a parallelogram, so the opposite sides are both congruent and parallel, and the diagonals occur, bisect each other, and all that good stuff. So let me get the right words for this one to show that these two are parallel, because this is a parallelogram. So this one's just going to be definition of parallelogram. Okay. The fact that the opposite sides are parallel, that's the definition of parallelogram. All right. Then we got angle AED is congruent to angle EBF. So AED is congruent to EBF. EBF, so it's congruent to this one. All right, and if you could visualize this, right, you got a pair of parallel lines, so DE and FB, right, so here's DE and FB being parallel, and then you have this one line going across it, right, going this way, and this is AB, and I'm saying that this side here is congruent to this side. And if you kind of visualize it this way, these are, yes, these lines are parallel, right? Got this, and here's your transversal, and what's the relationship between these two pairs of angles here that are congruent, and these are the these are the corresponding angles. So AED, parallel, congruent to this one, this is corresponding angles. All right, then it says EBF, congruent to BFC. EBF is congruent to BFC. Here's BFC, so it's this one. All right, so I'm saying EBF is congruent to BFC. And again, here's my two parallel lines here, so DC and AB and DF and EB here, and you have transversal going through. So now I'm referencing this angle and this angle. If you're looking at this diagram here, and this is alternate tier angles. All right, and then I got AED congruent to EBF, and then EBF is congruent to BFC, so therefore AED is congruent to BFC, and that's by the transitive property. Okay, and then we got finally that AE is congruent to FC, that's coming back to here, that's my given. I'm converting equality to congruence. So definition of congruent segments. So this is going back to my given, right? AE is congruent to FC, that's coming from here. AE is equal to FC, that's coming down that way. You draw a line from here to here. All right, and then we got triangle AED is congruent to triangle CFB. So triangle AED is this one. It's congruent to this triangle here. CFB. All right, and I'm able to do this with, okay, so proving these true triangles with, I have an angle here. This one was AED, BFC, AED, BFC. So these two triangles, so these two angles are congruent. That's with the transitive property. We got these two sides are congruent. Okay, that was with the opposite. All right, and then we also said that FC is congruent to AE. That was given to me. So by side angle side, I got those two triangles are congruent. All right, so now I got these two triangles congruent. And from here, it says AD is congruent to CB. So here's AD, here's CB. AD is congruent to CB, and that's just with congruent parts of congruent triangles are congruent. And now I showed that DC is congruent to AB, and now AD is congruent to CB, so I was able to show that both pairs of opposite sides of this quadrilateral are congruent. So both pairs of the opposite sides are congruent, and because both pairs of the opposite sides are congruent, it is a parallelogram. And that's the parallelogram opposite side converse. All right, so there's a lot in that one, so a couple of recap. How do you prove a parallelogram? Opposite sides are parallelogram, right? That's the definition. Opposite sides are congruent, parallelogram, opposite side converse, right? So if the opposite sides are congruent, then this is a parallelogram. Opposite angles are congruent, then it's a parallelogram. One pair of opposite sides are congruent and parallel, it's a parallelogram. Or the diagonals bisect each other, it's a parallelogram. Right, so these are all different ways to prove that this is in fact a parallelogram. If I tell you it's a parallelogram, then at the very least you can say that the opposite sides are parallel, right? And then all the other properties. If it's a parallelogram, then everything else goes into place too, right? If it's a parallelogram, the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other. That's everything you get from me telling you it's a parallelogram. Proving the parallelogram, you need one of these properties here from numbers 2, 3, 4, and 5. Opposite sides are congruent, opposite angles are congruent, one pair of opposite sides are parallel and congruent, or the diagonals bisect each other. Alright, so that's the end of chapter 7.3. See you on the next one.